Imagine walking into a workshop in the late 1700s. It is a place of incredible skill, but also of immense frustration. You would hear the rhythmic rasp of a metal file and the steady strike of a hammer against an anvil. If you looked closely at the workbench, you would see a craftsman laboring over a single flintlock musket. This artisan has spent days, perhaps weeks, shaping every individual screw, spring, and plate by hand. To the naked eye, these parts look like any others, but they are unique. They are siblings, not clones. If a screw from that musket were to fall into the dirt and get lost, you could not simply reach into a box and grab another one. No other screw in the world would fit that specific hole. The threads might be slightly wider, the head a fraction thinner, or the length just a hair too short. In this world, everything is a one of one. This was the reality of human production for thousands of years, and it was a massive bottleneck that held back the entire world. The problem with this system was that it did not scale. If you were a general in an army and 10% of your rifles broke in the field, those rifles were effectively useless until they could be sent back to a master gunsmith. On the battlefield, there were no spare parts, only scrap metal. A broken lock or a cracked trigger was a death sentence for the machine, as each repair required the same level of bespoke artistry that created the weapon in the first place. This lack of uniformity meant that maintenance was a nightmare and mass production was an impossibility. It was not just about weapons either. Think about the clocks on the wall or the locks on the doors. Every mechanical device was a puzzle that only its creator truly understood. If a gear stripped in a town clock, the repairman had to forge and file a new gear from scratch to match the specific quirks of that individual machine. This made technology expensive, rare, and incredibly fragile. The world was waiting for a bridge between the hand of the artist and the precision of the machine. The turning point did not happen overnight, and it did not happen because of one single person. Instead, it was a shift in how we thought about the very nature of an object. The big idea was simple but revolutionary. What if we could make parts so similar that they were truly interchangeable? This concept suggested that the identity of a machine should not depend on the individual pieces used to build it. If you had 1,000 muskets, you should be able to take them all apart, throw the pieces into a giant pile, stir them up, and then pull out random parts to build 1,000 working guns. To us, this sounds like common sense. To someone in 1800, it sounded like magic. It required a level of accuracy that the human hand simply cannot achieve on its own. The human hand is governed by the eye and the breath, both of which are prone to tiny, unavoidable variations. To achieve true interchangeability, we had to stop relying on the craftsman's eye and start relying on the machine's cold, repetitive consistency. To make this happen, a new set of tools had to be born. These were the machine tools, the machines that make other machines. Before you can have a perfect screw, you need a lathe that can cut metal with a precision that never wavers. You need a milling machine that can shave off a sliver of iron as thin as a human hair, over and over, without getting tired or distracted. These tools removed the element of human fatigue and the slight tremors of the muscle. But even more important than the machines themselves was the concept of measurement. For parts to be interchangeable, there had to be a standard. If my inch is slightly longer than your inch, our parts will never fit together. The revolution of precision machining was, at its heart, a revolution of the ruler. It was about creating master gauges, physical references that everyone agreed represented the absolute truth of a dimension. These gauges became the gold standard, the final authority that determined whether a part was perfect or whether it was scrap. As these techniques began to take hold in the early 19th century, the world began to change in ways that few people expected. The first big adopters were often governments and militaries because they were the ones who could afford the massive upfront cost of building these complex machines. They saw the immense tactical value in having a standardized arsenal. A soldier in the heat of battle could swap a broken part from a fallen comrade's rifle and stay in the fight. But soon, the logic of the system began to leak into the civilian world. Take the humble clock, for example. In the early days, a clock was a luxury item for the wealthy, a handcrafted marvel of brass and wood that required constant attention from a specialist. But when manufacturers started using precision dies and interchangeable gears, the price plummeted. Suddenly, a middle-class family could afford to keep time. The clock transitioned from a piece of art to a functional tool found in every home. This synchronization of time across society would eventually allow for the organized movement of trains and the birth of the modern schedule. This shift created a new kind of economy. It gave birth to the factory system as we know it today. In the old way of doing things, a single person might build an entire product from start to finish. They were a master of their craft, understanding every nuance of the wood or metal they worked with. But in the new world of interchangeable parts, the process was broken down into its smallest components. One person would operate a machine that made one specific part over and over with perfect accuracy. This made production incredibly fast and the products incredibly cheap. However, it also changed the lives of the people doing the work. The pride of the master craftsman was often replaced by the repetition of the factory floor. We traded the unique soul of the handmade object for the democratic availability of the mass-produced one. It was a trade that built the modern world, but it came with a heavy social cost, as the worker became as interchangeable as the parts they were producing. The ripple effects of this precision reached into every corner of life. It made the steam engine more reliable because the pistons could now fit tightly inside the cylinders, preventing the waste of precious energy and allowing for higher pressures. It made the sewing machine possible, which revolutionized the way clothes were made and worn, moving humanity away from the loom and the needle toward the garment factory. It eventually led to the bicycle, the typewriter, and the automobile. None of these things could exist if every bolt and nut had to be custom fitted. We began to live in a world of standards. We standardized the size of pipes, the pitch of screw threads, and the thickness of sheet metal. This hidden framework of precision is what allows a light bulb made in one factory to fit into a socket made in another, across the ocean. It is the invisible language that allows our global supply chain to function. Without this shared agreement on measurement, the modern world would grind to a halt. Even today, we are still living in the era of the interchangeable part, though we have taken it to levels that the pioneers of 1800 could never have imagined. We now talk about tolerances in terms of microns and nanometers. We use lasers and computers to ensure that the components of a smartphone are so precise that they fit together with almost no gap at all. This level of perfection has become so common that we do not even notice it. We only notice it when it fails, which is rare. We have reached a point where we expect things to work perfectly out of the box, and we expect that if something breaks, we can simply order a replacement part online and have it fit perfectly when it arrives. This expectation of perfection is a direct inheritance from the machine shops of 2 centuries ago. The legacy of this movement is a world of abundance. It is why we can have complex machines in our pockets and reliable transportation in our driveways. It shifted the focus of human ingenuity from the struggle of making one thing work to the challenge of making a million things work exactly the same way. It was a victory of system over chaos, of measurement over guesswork. When we look back at the history of technology, we often focus on the big, flashy inventions, like the steam engine or the airplane. But none of those would have been sustainable or scalable without the quiet revolution of the machine tool and the interchangeable part. It was the foundation upon which everything else was built, providing the structural integrity for the industrial age. As we moved through the early 1800s, this mastery over metal and measurement gave us a new sense of power. We felt that if we could control the physical world with such precision, there was no limit to what we could fix or improve. We had standardized our tools, our weapons, and our machines. But as we looked around at the world we were building, we realized there was one area that was still messy, unpredictable, and deeply manual. While we could now repair a broken musket by swapping out a part, we still had no way to reliably repair the human body without causing immense agony. The precision of the machine shop had not yet reached the operating table, and the next great challenge would be to bring that same sense of control and progress to the world of medicine. Surgery remained a brutal, hurried affair, more akin to the work of a butcher than the work of a precision engineer, because the patient could not remain still or painless under the knife. That concludes our look at how interchangeable parts and precision machining fundamentally reshaped the industrial landscape. We have seen how the transition from the unique to the uniform paved the way for the modern world, creating an environment where technology could be mass-produced and easily maintained. We are now moving forward in our timeline to the mid-19th century to see how the next major breakthrough changed the stakes of human life itself. In our next episode, we will explore the arrival of anesthesia and the birth of modern surgery. We will see how the quest for control over the physical world finally began to address the most fundamental problem of all, which is human suffering. If you are enjoying this journey through the history of technology, be sure to subscribe.